for these two exponential, all right, for these two index number, we know if the base is the same, then the power, the index must be the same. So we can simply do 2x minus 4 equal to negative x plus 2. Does it make sense? Yeah, so everyone know how to do it and then become a solving equation. Yeah. And that will become a like year 7, year 8 solving equation question. However, this question is not 5. This question is 25. So we can't just make these two guys equal, right? So we need to make the two base the same. Can we look at the relationship between these two guys? Yeah. What is the relationship between them? Yeah, this is 5 squared, right? So we can represent 25 into the form 5 squared. Does it make sense? Yeah?
Can you also just multiply the other one by 5?
No. Alright. The reason why I put it in a square form instead of multiple by 5 is because we know the index law, okay? So we're not going to spend much time on index law. We know that. So let's say A3 times A4, that would equal to 3 plus 4 for the power. Okay, however, it's A3, 4 in this way, you times them. Does that make sense? Okay, so that is something we learn in junior. Okay, we're not going to spend much time when we do year 12. So in this case, we can put the square outside the bracket. Does it make sense? So that will become negative 2x plus 4. All right, now it becomes something. Now it becomes something that we can actually solve, right? So we can get rid of the 5. Okay, what happened? Then you change the table.
You guys stop complaining yet?
How about now? Oh, good? Does it make sense? So now you simply make these two guys equal and solve x. And there you go. Alright. So. Oh, good? Okay, then let's talk about the next one. Can I wipe it out? It's recording anyway, so you guys can watch. Yeah, it's recording this. So so that's why I said we're gonna spend only 4 lessons on this. So I will speak very quickly, all right? And then I probably don't have time to check your understanding. If you don't understand, watch the video again or ask me on Teams anytime. And even next time, if you forget anything, you can refer back to it, and you have the booklet too. The question is corresponding to this video. All right, the next one. 9x equal to 12 times 3x minus 27. Okay, how do we solve for x here? All right. So this one, if we don't have the negative, like the subtraction thing, probably we can use the previous method. But now we have this one, and we need to look at the relationship between these two guys. What is the relationship between them? Same as just now. 5 and 25, the relationship is this is the square of 5. 9 is the square of 3, right? So if we write in this way, 3, 2x, this way, equal to 12 times 3x minus 27. Now, what can this equation remind you of? Quadratics. Quadratic is something square, all right? Something square, and then power, let's say something like this. Okay, this is a quadratic, right? So this one is sort of like quadratic. Okay, so but Carmen was like shaking his head. It doesn't look like quadratic. Yeah, it doesn't look like. But if we say let 3x equal to a, or Count me if you want to. We can equal to cow. Okay. 3x equal to cow mean. Okay. So now is cow mean square equal to 12 cow mean minus 27. Now it looks like quadratic. All right. Now it looks like a quadratic. Does it make sense? Oh, can you guys solve it with cross method? Okay, have a go. Oh, that's right. Okay, let's have a go on this one. This one is not on your booklet, but let's write it down on your booklet. I suddenly remembered this. This is a past exam question. It's 2015. Let's copy this question down on your booklet and then let's have a go on this. The second strategy we talked about was to make it like a quadratic form. But this one we don't have a to the power of 2. So how can we do it? But we have something like this. What if we times, if I want to get rid of the negative, the power of negative, what if I times ET for every single term? What will happen? So this one would be 3 ET squared. Make sense? If I times ET for this term, so you have 2 ET, and this one is equal to 5 ET, and this one, this times this, what does that equal to? EET times ET. All right, there's two ways for you to do it. Number one, we use the exponential law, which is the base is the same, then we remain the base and we do addition for the top. So that would be 0, right? So this 0, which means this is 1. Does it make sense? So which means this is 8. 8 times 1. Yeah? Make sense? Or another way, we can convert this one. When we did a lot of this kind of conversion when we're learning differentiation, right? So this one we can make 1 over ET and times ET. Now this case we can cancel out. Oops. Equal to 1. There's two ways for you to do it, right? Okay, so now it becomes a quadratic. So let's let ET be A. Okay, then 3A squared equal to 5A plus 8. Now it becomes a quadratic. If you move it, all right, if you can use cross method, then use cross method. If you can't, use quadratic formula. If you want to solve a quadratic, there are 3 ways for you to solve it. Number 1, cross method. Number 2, quadratic formula. Number 3, complete the square turning point form, right? But that one is more complicated. Coming? What's the solution for this one? Quadratic formula. So yeah. This is 1, 2, 1, which means this is 11. 5 plus 11 over 6 or 6 over 6. So that would be 1 or 0. So it will be this 2, and then ET will equal to 1 or ET equal to this. And then T equal to something we will learn. Log something. Alright? Yeah, so we will learn that. Okay. So now we're gonna talk about the logarithm. First of all, we know the relationship between logarithm and exponential. So let's say 2 to the power 3 equals to 8. Okay, and how do we write this in the log form? How do we write this in the log form? That would be log EA equal to 3. So basically, the base is the same, all right? And this one represents the power, or we say the index. Okay, so this one is here, and A is this guy. Yeah, so this one 2 to the power of what? Equals to 32. There you go, this is 5. Does it make sense? Okay, before we talk about the next question, I'm gonna give you the laws of logs first. So let's do some revision on exponential law. Power of 4. What is that equal to? Toby, can you tell me this one? A7. Yeah. For log, exponential and log, they are actually inverse. They're inverse function. So that's why a lot of things they go opposite. So if we look at here, this one is times and this one is plus. Does it make sense? This is times, this is plus. For logarithm, we just go opposite. So let's say if it's log A3 plus log A4, you will get log A12. Because they are opposite. If you can't remember, I know some of you after like 2 months or 3 months you haven't done anything about log, you will forget. You will know, you will like, oh, is it plus or times? So the best way for you to remember is that, because everyone knows this one, log goes opposite with the exponential. If exponential, you times it and then you eventually plus, then this one is log plus log, and the result will be times. It go opposite to the exponential. Does it make sense?
What happens if log times log?
I will tell you. Log times log. We are not doing that. Okay. Yes. Yes. Okay. Shh. All right. Then now let's continue. So now if we know this one, now let me ask you one. How about log? Let's say 4. Let's say A plus log 4, 8. What would you get this one? Log 4, 64, because you times it, right? Everyone, this is very important, okay? This is another law that I'm gonna prove to you. Okay, so this times this equals to 64, right? Can I write in this way? Log 4 a squared. Because a squared equals 64, right?
Yeah.
Does it make sense? Everyone agree with that? Okay, now let me ask you. Something plus something, if we use year 1 knowledge. Okay, year 3, maybe year 2. Anyway. Kindergarten in Korea, okay? Alright, so we know 1 plus 1 equal to 2 times 1. Make sense?
Okay.
So this guy plus this guy, does it equal to 2 times this guy?
Yeah.
Okay, now we have another law. So which means if we put this power in the front, they will still equal.
Wait, sorry, say that again?
You still stay in grade 1 now.
Okay,
Oh my god.
say it again.
Okay, so, alright, so this guy plus this guy, by the law, alright, we just did, so we know it's A times A equals 64. And we know 64, we can write in this form, A squared equals 64. Does it make sense? And also with the left side, this one, this guy plus this guy, we know is 2, this guy times 2. Make sense? So which means this equal to this. And if I write it down, we know that we are simply put this square in the front. So this is another law, okay? So this one, if you put in the front, they still equal.